document presentation. So what we perform in this work, it is to make a virtual restoration of the document. So to recover from, or try to recover from, to the original aspect of the document, removing the bleed through automatically from the document. What we intend to have, it is both producing a binary representation of the document itself, which may be useful for many purposes. For example, if you have to perform OCR on the document text, and also to preserve the document visual characteristics, which maintain also the visual representation of the background and to reconstruct its original appearance. So here it is an example of a document having a very strong bleed through. You can see the recto part here and the verso part here of the document, so the two sides of the document, and you can see the bleed through that appears. And the result of the virtual restorations is something like this one. So it has been removed most of the content that was undesired, but it is maintained, it's preserved. Other parts that were almost not visible at the beginning, like this stamp, but also the paper forms that are present here. So the proposed solution in this paper, the main characteristics of the method is that the method is based on the use of both sides of the document, the recto and the verso, and we intend to produce a realistic version of the original document, as well as a binary representation of the document. The method uses a very simple multi-layer neural network, and it is based on the training of the network. It is based on the use of the degradation data model. This is one of the key aspects of this method, because the use of this model will allow to simplify the training phase of which is one of the most expensive parts of the use of neural networks. The method can be easily, the other advantage is that the method can be easily adapted to the manuscripts that to be restored. So while in many cases when you are using a neural network, since the training phase is quite expensive, you just train the network for one set of limited set of documents and then try to use to many others. In this case, you can either do this in this way, but you can also train the network specifically for the document that you are trying to restore. The network classifies the document pixels, each pixel of the document as belonging to one of three classes. So the foreground, which is the part that we intend to recover, the background, which is the part that it is the paper content, and the bleed through, which is the part that has to be removed. And we experimented also the use of 4 classes instead of 3, which are the 3 that we used, I described before, plus another class which we call a occlusion class, which is basically a class where we have at the same time, in the same pixel, both foreground and bleed through. These pixels are the most difficult to be recovered in when you use other methods that we experimented in the past, and and as we will see, the use of 4 classes improves the quality of the restoration. And the method substitutes the bleed-through pixels with the pixels taken from the background. So here it is an example on how the training set is built. In many, what we have to do is to select a significant number of document patches where we know precisely the class of each pixel. So if it belongs to the foreground, the background, the bleed through, and eventually to the occlusion, we are using 4 classes. So the expensive part here, it is usually to be able to recognize, to know precisely which pixels belong to each of these classes for the training set. The use of the model simplifies this the creation of the training set, as we will see. So let's first look at the degradation model. What we use a non-stationary convolutional mixing model for the recto-verso to model the bleed-through degradation. So basically, what we have here it is that we work at density level. Instead of representing the intensity of each pixel, we represent the density of each pixel, which is a better representation of amount of ink that is present on that pixel. So the density in a specific pixel that we observe, this part here, is on the rectal side, for example. It is given by the true density, so the original document without any degradation, plus an element which takes into account what has been transposed from the other side, which is this one, with a convolution with a point spread function, which takes into account the fact that the ink usually, when transfers from one side to the other, diffuses on the paper, multiplied for a factor which is the interference level, because different parts of the document, the interference level can change. And the same thing is for the verso side. So this model, if we try to solve this model to recover the original representation of the pixels from this equation, we have many different parts which are unknown. So it is the problem is an Hilport's problem, which creates problem. Can be solved only approximately. And this has been done in some of the previous works we did, and it is possible to do that, but the quality it is not as good as we have in this method, where we use the same model, but we use in its direct form, mainly just to generate the training set. So using it in the direct form doesn't create the problem of inverting this equation. So how we build the training set? In this example, we have an example of the recto side, an example of the verso side. We have to select small blocks from the recto and from the verso, which do not contain any bleed-through. So in any document, there are parts that are free of degradations, and we have to select these parts. So then, using the model, we create the mixing of the two parts. So we artificially create a bleed-through patch. And through binarization of these two patches, these two, which is, since these are free of bleed-through, it is quite easy to be done. We can recognize precisely for each pixel of the patch the background, if it belongs to the background, to the foreground, to the bleed-through, if it is taken from this other side, or for the occlusion in case it is both foreground and bleed-through. So we easily create the true values for the training set. So also, as if you remember the model, I said that we have we may have different values of Q-values of transparency of the paper. So since we have to emulate this situation, we for each couple of patches, so for each patch of the recto on the verso, we create different mixing with using different values of Q in the model equation, which takes into account for the different possible levels of transparency of the paper. So the architecture of the network, just few words, the creation of the network in terms of time to create the network, it is quite fast. It takes on a standard PC, it takes less than a few seconds, because it is the network is quite simple and it's not very complex. And this is the architecture of the network. So in input we have the two nodes, the recto and verso densities, that are passed to a hidden layer, which is composed of 10 nodes, and uses as output a sigmoid function. Then the output layer, which uses as output a softmax function, produces the 3 or 4 classes that are the result. The restoration procedure, this is an example of the recto verso of a document with degradation. We used here a method for we split the original recto and verso into different patches again. And in this case, the splitting of the patch, and we restore each patch by itself, and then compose the result in the final document. This because what may happen, and it happens mainly, many cases, is that the recto and verso document are not registered. So the registration process could be expensive and could produce some not good results, depending on how the registration has to be done, which kind of problems that are in the registration phase. So we selected the 2 pages in order to have the possibility to just register the 2 pages through a simple shift of the patch itself, so which doesn't introduce these artifacts in the document. So the single block restoration. So we first perform this alignment of the 2 blocks, and we have this result here. And then we pass this through the neural networks, which is able at this point to select for each pixel of the block, if the pixel belongs to the background, the foreground, to the bleed through, or it is an occlusion. And then at this level, we already just taking the foreground pixels, we already have the binary representation that can be used as one of the first results. Or if we want to have, as I said at the beginning, a realistic document, then we, by using these 2 original patches, and by using the information of which are the pixels that belong to these 4 classes, we remove these pixels from the document, and we perform an inpainting of in order to inpaint these pixels here with pixels that are from the background. So we obtain a background patch that at this point we just take the foreground pixels, put them on this background, and we have the recto restored. So, a few words about the experimental results. We made up to now we made a qualitative evaluation with a comparison with other restoration methods, and a comparison with a binarization technique that was one of the winners of the handwritten document image binarization context. And we tried to experiment also to see if if 3 or 4 classes are which of them it's more convenient to be used. And we also experimented with different levels of degradations to be used. We first experimented on synthetic documents, which are convenient because we know precisely what is the expected result that we have to obtain. And this is an example of the recto verso of synthetic document. And the synthetic documents we created basically are with different levels of degradation. So from this side, on this side, we have no degradation. And if we go up to the right side of the document, here we have a very strong degradation. So these are this part of the document is very difficult usually to be restored. If we look at the result of the restoration, this is the expected result, the best, the original document with no degradation. And with this is the result with if we use 3 classes and if we use 4 classes. So you can see that in both cases we have acceptable results. But if we use 4 classes, the quality of the result is much better. For example, if just I take this part here, you can see that this letter here is completely restored, while here some pixels are missing. And also this happens in many other places. And so 4 classes, and this is true also for many other examples that we did. So the use of 4 classes is usually much better than the use of 3 classes. And this is a comparison with the our method with the HDCO competition winner. We can, this is obviously we can just compare the binary representation because the HDCO produces a binary representation of the document, and we can see that our method produces quite good results for all parts of the document. And here there are some missing parts that are still not recovered, not eliminated, but in terms of quality is quite good. While the HDCO, it is very good to restore the document if there is no degradation, no bleed through, but when there is bleed through, it obviously completely fails in the results. Looking at the real documents, this is a real document with a limited degradation, which is at various levels in the document itself. And again, you can see that the quality of 4 classes is much better than the quality of 3 classes. And again, if we compare the result of the binarization with in the real document compared with the ground truth, because in this case we have a ground truth for that document, and with what HDCO produces, we can see that also in this case the HDCO doesn't recover completely. For example, this part, this letter here, it is not completely restored, and this part here has some parts that should not be present in the document itself. Okay, I had some other examples here that I skip because we don't have much time, and I just go to the future work that we plan to do. As I said, we have we made a qualitative evaluation. We intend to continue the work doing a quantitative evaluation, which is quite straightforward because we have, at least for the synthetic documents, we have the precise ground truth, but also we have a data set that we used in other cases with ground truths that can allow us to make the quantitative evaluation. And we intend to precisely arrive to a precise result in terms of deciding if 3 or 4 classes have to be used. Then, since we use a degradation model, the further work we intend to do is to work on a model that doesn't work at pixel level, but works also at pixels with an area around the pixel itself. Because as I mentioned, one of the bleed through is has usually the ink spreads when passes to the other side, so it would be important also to take into account how this spread is done. The third point is since the selection of the blocks to be used for the training set is done manually. As I said, we have to select these blocks which are doesn't contain any bleed through. We would like to have a complete automation of this procedure in order to have a further speed up of the procedure itself. Okay, so I concluded my presentations. Thank you very much for your attention.
For your interesting talk. Are there any questions or remarks? Yeah.
Yes.
The technique that you use to binarize those documents.
Can you speak louder, because I have some.
The technique that you use to binarize those documents.
Yeah.
Is a local one or a global one?
To binarize, I think it is a local one. It is we didn't investigate the technique. Not we use. Are you saying the HDBCO?
Yes.
Yeah, the HDBCO. I think it is a local one. The difference with our method, I must be honest, it is that they are using only a single side. So we are using both sides, so we have more information that they have. So that's what is the reason also, because we have much better results. So I think that it's almost impossible to perform a very good binarization of documents with a strong read-through if there is if you don't have the information on the other side. But we just selected that method because it is one of the best methods that is available, and we have the possibility to experiment with the code that they made available on the webs. Yeah.
Just curiosity, in your future work, are you planning to try convolutional networks? So are you, like, why you mentioned better automatic way?
Sure. Yeah. Sure. This is a much longer term work. It obviously another, but it would require some more time. It is to try to use the convolutional neural networks and also to compare with the use of a very simple neural network. So the first idea we had is basically the problem that we have at hand. It is a classification problem. Since it is a classification problem, why don't we try to just use the most simple way of using neural networks for a classification problem? And frankly, I was quite surprised to see that we had good results. But obviously the point is using a more complex network, more way, it should give better results. But I think it would be also interesting to understand if really in this kind of problems, it is really necessary to have to approach the problem with a convolutional neural network. Yes.
Okay. I have a question.
Yes, sure.
In one of your last slides. Okay. Here.
This one? Yeah.
Yes. You compare the results, the two results with the ground truth.
Yes.
So the question is, with which method of indexes you compare? You make this comparison.
Okay, this is just a visual comparison, but it is possible. We in other works what we did is we compare with the using precision record. So the number of pixels, of true pixels that have been recovered from the ground truth, and the number of wrong pixels that have been that are still present in our basically.
There are many
Yes. Yeah. We compare. We intend to compare with precision record method technique that it is used also by people in other works. So we can also compare our results with their results. Yeah, sure. Because also it's important this comparison with the work by other people.
Okay, thanks very much.
Thank you very much.
And so now there is a little change. Next speaker is Professor Francesco Marchetti, and he will talk about mapped variable scale kernels application to solar imaging. Giulio, tu sei collegato?
Sì.
Giulio, siccome io non vedo, ci sono altre persone collegate?
No, sono solamente io.
Perché poi ci dovrebbe essere Tala Mahmood, che è una speaker. Devo capire se è presente. Semmai tu hai l'indirizzo di questa Tala Mahmood?
No.
Non so se era in presenza.
Sì, è in presenza.
In presenza?
In teoria sì, vorrei controllare.
Ok.
Questa qui?
Sì, sì.
Giulio, se non ci dovesse essere, parli te.
Beh, comunque è previsto che parli anch'io stamattina, no?
No, scusa, infatti, Giulio parla in ogni caso. Sì, ma di lei è l'ultima.
Esatto.
Sì, no, scusami Giulio.
No, di nulla. Magari provo a contattarla o contattare comunque l'autore dall'indirizzo email sul paper.
Sì, magari, grazie.
Di nulla, faccio subito.
Infatti,
Mhm. Mm.
No.
Dice che tipo devi pagarla.
Sì, slideshow.
Dove vedi?
From beginning.
Ok.
Che scegli tu poi.
Vai così?
Sì, quindi ti do poi. L'unica cosa non so, quelli che vedono dovrebbero vedere solo questo qui tutto sul schermo, però non sono sicuro. Beh, una prova, aspetta.
Io vedo la view rappresent, non la presentazione.
Preset. Duplicate slideshow. Ok, sì, siamo sicuri. Aspetta.
Ok,
Però qua non sì, no, sì. Ok, perfetto.
No, tanto cioè non è insegnato il resto
E comunque chiedi
ma
dove sei? Non lo so. Senti, posso dare il tuo numero? Ascolta, segnati questo numero. C'è un numero da segnare. Ti faccio chiamare.
Okay. Thank you. It's really nice to be here, this wonderful city, nice workshop. So, I will talk about mapped variable scale kernels, and you will see also an application to the solar imaging context. Okay, this is a joint work. First of all, with Emma Peracchione, but then also with other people, Stefano De Marchi from the University of Padua, and Anna Volpara, Anna Maria Massone, Michele Piana from the University of Genova in the MEDA group. So the MEDA group, they treat this kind of imaging problem concerning solar imaging of space weather forecasting applications. So that's why the context where this application had birth. So before in the last part, I will talk about this application, but before I need some introduction. So I will start with the introduction of the kernel-based approximation setting. Then I will propose, before proposing the main idea, which is in the, let's say, part 4 of this outline, I need to recover 2 approaches that have been studied in the last years, especially in Padua. by our group that are variable scale kernels in the context of kernel-based approximation. And the other approach is more general in the sense that it can be applied, as we will see, in the kernel-based setting, but it can also be applied in polynomial approximation, so on, which is it is a mapped basis approach. Okay, we also call it fake nodes, and I will explain to you why we decided to call it also this way. Okay, so kernel-based interpolation face the classical interpolation problem by considering a strictly positive definite radial kernel. So let's say that we are in some domain in RD, we have this k epsilon, which is a strictly positive definite radial kernel. Radial meaning that its evaluation depends only on the distance between its arguments. And so usually this kernel depends on a shape parameter, epsilon, and the role of this shape parameter is to do the shape of the basis function. So if it can get more narrow or more flat, so think of the Gaussian, for example. Okay, so you can play with this parameter, and it is important usually in this context to tune this parameter. Then we have a classical interpolation problem. We have a set of distinct nodes, and we wish to reconstruct a function on this domain, knowing its samples at this set of nodes that we introduce, x. And our ansatz is this function here. So the interpolate is a linear combination of basis functions that are constructed via the kernel that we introduced. Okay, so as one usually does, to construct this interpolant, you need to find the vector of coefficients, and this vector of coefficients is determined using the interpolation conditions at the function values that we get. And this is done by solving a certain linear system that involves what is called the kernel matrix K and the vector C and the vector of function evaluation values. Okay, and sometimes we may use the abridged notation to avoid to denote the shape parameter if it is not necessary. So the interpolant, so constructed interpolant, belongs to a dot product space in principle. That is the space. This is the space generated by the function created via the kernel. Okay, and the completion of this space with respect to this norm, which is induced by the bilinear form provided by the kernel, is the native space associated to the kernel. And this is important because most theoretical results relies on this native space. And in particular here, I want to focus on a couple of results, particularly this result that is a bound, a pointwise error bound between f and its interpolant. So there are some hypotheses, so I won't focus on that. What I want to say about this bound is that it depends on the norm of the function in the native space and on the so-called field distance. And I will provide a picture of this field distance to get an intuition. What is that? So what this bound is saying is that if this field distance is really small, then we can expect to have a faster convergence, because of course this field distance is then elevated to the power of k that depends on the regularity of the kernel. So regular kernels and small field distance seems to provide the best approximation rate. On the other hand, we have a problem of stability usually, and this stability that affects the interpolation process, the yield conditioning, sorry, that affects the interpolation process is usually caused by there are two items that play a role. The first is the separation distance. So this is a picture of, I cannot see it. Okay. So this is a picture or representation of the separation distance. So this is a data set. The separation distance is the maximum radius of a circle that you can place on each point of your data set without intersecting other circles, other balls. Okay. And the field distance here on the right side is the radius of the maximum ball that you can place in your domain without touching any nodes. Okay, so the separation distance gives you an intuition, a quantification on how much your data are clustered together, and the field distance provides to you an intuition on how much, to what extent the domain is filled by your dataset. Okay, so we would require this field distance to be small. Okay, and the problem with the separation distance is that as the separation distance gets smaller and smaller, which is natural if you think of increasing the number of nodes, which is what you usually do when considering some asymptotic grids. So if the separation distance becomes smaller, then your problem gets more and more reconditioned. And also another problem relies on the tuning of the shape parameter of the kernel, because moving the value of the shape parameter can determine really different results. And so there are many trade-offs here. They're also called uncertainty principle in the RBF context in some sense, and we have to deal with that. So we have to keep, let's say, a not so small separation distance, but at the same time, to not let the field distance be that large. Okay. So the idea of variable scale kernels was to substitute the tuning of the shape parameter by means of a shape function or scaling function. So the evaluation of a variable scale kernel on omega times omega is equivalent to evaluate a standard kernel in an augmented dimension. So you have your data x, y, and you map them to the dimension rd plus 1 by using a shape function, psi in this case. And so if you choose psi in a good way, for example, you can choose psi to increase the separation distance of your dataset, then you may achieve better results with respect to standard interpolation. Or for example, we studied some approaches where when dealing with discontinuous function, you can choose psi in such a way you can replicate the discontinuity of the underlying function, and in that way you can really improve your approximation by getting rid more or less of the Gibbs phenomenon. So this is a very nice approach that we would use. And another approach that we will use to construct our kernels is the so-called mapped basis approach. So it is kind of similar in principle. There are many similarities, but what you do here is to consider an injective map S, and you want to construct an interpolant in the mapped space where this Ks is defined in this way. So Ks of xy is simply the kernel, standard kernel evaluated x as y. And as long as this map is injective, everything is fine. And so the interpolant can be written in this way in the mapped basis. And actually, this interpolant is equivalent to a standard interpolant, where in place of your original nodes, you're considering the so-called set of fake nodes, let's say. That's why we call it fake, because they do not exist in your problem, but you are thinking of taking your node, moving them to some better place, say for improving the stability or the accuracy of your method, and then you reconstruct there, and then in some sense you come back without actually inverting this map as script, and this can provide you better results. So in this final part for the application I'm going to show you, we will consider a mixed approach where we'll take both variable scale kernel and the fake nodes approach. And so we construct a mapped variable scale kernel, and you can see that in our approach, this was a choice. Actually, you may choose stuff differently. We decided to do not mix S and psi. This is because then you can better handle both of them. If you mix them, maybe you can get some intersection. You're not sure who is playing the role, which one is playing the role of what. And so S of X, S of Y are playing in the original dimension, and C of X, Psi Y are really the augmented dimension, as in the VSK case. Okay, so we keep these things separate. So this approach, we are going to apply it in this context. It is the context of STIX telescope, which is a telescope that is on board Solar Orbiter. Solar Orbiter is a NASA mission that was launched like 3 years ago. And the idea of this telescope is to provide some measurements in the X-ray plane. Okay, and these measurements are named visibilities. And what you measure is the Fourier transform of the incoming photon flux at some specific point of the spatial plane that you are seeing. And you can see here spatial frequency plane that you're seeing. And you can see here what kind of visibilities we have at disposal and are this one. Then you can replicate them and get this full set of visibilities. So these are our, let's say, interpolation points, approximation points. Okay. So the idea of this instrument is to basically look at the sun and looking for example, flares, other phenomena like that, to try to reconstruct them in a better way with respect to previous mission. Okay, so this is going really, really close to the sun, between Mercury and the sun, so it's really getting really, really close to the sun. Okay, so in the approach that we are following is an approach that was already carried out in a previous NASA mission, RESI. So the idea is to interpolate the visibilities to obtain some visibility surfaces, and then when you have your visibility surfaces, so you have a full function reconstructed on the Fourier domain, you go to the spatial domain, which is what you're interested in the end. So, and this idea, yeah, was already used and was called in the context of NASA, they call it UV smooth. And so our idea is to use this mapped variable scale kernel for this UV smooth, because in principle UV smooth does not okay, you have to choose your interpolation scheme, let's say. Okay, so this is the general idea, but then it's your choice about the interpolation scheme, and we want to try this mapped variable scale kernel because variable scale kernels alone already provided some nice results in the last month. Okay, so just a few words on what we choose for Psi and S. So for Psi, we choose a scaling function that take advantage of a first approximation of the inverse problem. So you take your problem, you get a really rough approximation of your function, let's say, via standard back projection. And so this approximation is really rough, but then if you project, use a back projection, and then you forward transform to the Fourier domain again, you get some approximation, really rough approximation of your function. You can use this function Psi as a sort of a priori knowledge of your function. And as far as S is concerned, we consider this map S, and I will show you a picture why we're choosing this one. The idea is to separate. So since we have these interpolation data are really clustered around the center, and as we saw, this is a problem from the separation distance point of view. What we want to do is to separate these points, okay, to get a better stability. So you can see here a picture of what we are doing. So these are the original data, and these are the final data mapped by S. So this is just a representation. This does not actually take place in the sense you just pass from here to here with the map, but it is just to give an idea of which point goes where, okay? So you are considering that map that will eventually put your point from here to this corona. And these are some results. So just some comments on these results on the bottom right. We can consider them as a sort of ground truth. So these are images of the sun surfaces, okay, a reconstruction of flare events. And this image here is provided by what is called MEMJ, which is another kind of approach. It's not an interpolatory approach. It is really slow, but it is considered one of the best approaches so far. So we can, let's say, compare the results of this well-established approach to our results. So on this upper left side, you can see results obtained via standard approach with RBF. And you can see that here, really, we are really achieving something that is, yes, too flat, okay, with respect to the reality. And on the upper right side, you have the results achieved by using just VSK. And on the bottom left side, you have the results. Sorry, no, this will not again. These are the results achieved by our method. So you can see that, and this is also assessed by some statistical indicators, but I'm not showing it now. So you can see that we are going towards, with our approach, we are going towards the direction of MEMJ. We are trying to replicate more this kind of shape here, and this was not possible in the case of standard VSK and the standard kernel approach. So this seems like a nice direction to continue to investigate in the next month to see if it can actually even improve the approximation and even getting closer to the MEMJ reconstruction. Okay, so my talk is finished. Thank you for your attention.
And are there any questions or remarks?
So I'm wondering if there is a way of doing a quantitative evaluation of the quality of the method. So basically, as far as I understood from the last slide, it is a qualitative evaluation.
So
it is a way of trying to just simulating it. So you already know the ground truth basically. You know what is the result, and you just miss some of the points and just trying to reconstruct them to your method. I don't know if there is also a way to measure quantity.
So yes, so in this, so far it is just some time that are, so in the first phase of the mission, of course, there were not real data. So what they wanted to do, what they did, especially it was Emma Bracchione that was dealing with this part. So they generated some synthetic data and they tried to play with them. And actually here I didn't show you, but you can assess quantitatively the quality of your approximation. For example, they use some, for example, chi-square index, some statistical approach to quantify if you are going. Okay, so they actually can quantify that. Sometimes you cannot see. So the visual part is still important because sometimes with the kind of indicator they are reliable, of course, but you can maybe a small improvement seems really small in the quantitative indicator, but if you look at the picture, something is really seems like it is a different picture. So I think that so they are measuring quantitatively. Maybe in the future they can also take into account different measures, for example, SSIM, some other indicators. But as far as I know, they didn't take into account yet this kind of indicators. But
Okay.
Where did you get those solar images from?
From the telescope.
From a database or
There is no so these are reconstruction from real data, actually from a flare that was the last autumn, don't remember now actually. And so there are some nasal repository that you can get access. Yeah, so I think that many of them are also free actually. So maybe sometimes not, some not, but the most part of them are completely free. Maybe you have to enroll to start to register to some site and so on, but you can download data and play with them. Yeah.
Okay. Concerning the variably scaled curve.
Yeah.
As far as I understood, they are good in order to reconstruct the discontinuous function. You told before.
Yeah. Also, yeah.
Okay. The question is, when you reconstruct the discontinuous function, you should have a Gibbs phenomenon.
Yeah.
So how they describe this Gibbs phenomenon?
Yeah. So.
It is a curious.
Yeah. So the fact is that, okay, let me come back.
What happened? When you reconstruct with this.
So when we use this approach to reconstruct this continuous function, we take a function psi that is usually piecewise constant, and it is constructed in such a way, okay, in a say theoretical setting, you can do that precisely, otherwise you have to estimate something, but okay. So we construct psi in such a way that the discontinuity of the underlying function are contained in the boundary of this piecewise constant defined function, okay. And so the fact is that this approach automatically generates a native space of generated by functions that are discontinuous exactly where you need it. So the problem with the Gibbs phenomenon is that you have a discontinuity and you're trying to reconstruct to replicate that discontinuity by using continuous functions. And so you have some problem because you can get precise, but in the end you have some overshooting. But if your basis function is in principle discontinuous there, you don't have this problem because your discontinuity is natively, let's say, included in your basis, and so you can find the right linear combination and you don't have overshooting because
so this means that in the discontinuity point the reconstruction is a linear combination of the for example of the right and left limit, something like that, or no?
No, it's more like that you are considering functions that are so you can think of that they are discontinuous where the function you have to reconstruct is discontinuous, and so it's not something you're not even considering some limit from the left from the right, because you are when you consider your linear combination of functions, this linear combination of functions is already set to replicate the discontinuity in that position. And so by simply considering a combination, you just end up with you can end up naturally with some gap without thinking of
some limit point. I mean,
okay, yeah, I understood what you mean. Okay, so it depends. I think and actually never had a tight look on that, but I think it depends, for example, on which point. So when you construct the partition of the set that determine your piecewise function, so basically in that case you decide if you are approximating by the, let's say, by the right or by the left, because if you consider a piecewise function that includes, for example, the discontinuity from the right side, so in the end your reconstruction will be continuous from that side, and on the other way around you have discontinuity. You will not from the left side, let's say, you will be approximating the basement of the jump, let's say. So I think this depends on the way you construct your piecewise function, but I never had a.
That's why there could be a linear combination of the right and left limit, because usually when you try to reconstruct the point where the function is discontinuous, usually you get in some case there is no reconstruction, but when there is a reconstruction, it is a linear combination of the right and left limit. For example, in one-dimensional case.
You mean that you go towards the middle point?
Yes, it's based on the Fourier transform.
Yeah. No, you don't get something like that. Okay, you don't get like that. Like in discontinuity, you don't get some middle points like in the Fourier series context. You belong to one side or to the other side, depending on how you define the scaling function, actually. But I never had a really tight look on what's happening. We were happy with the fact that the Gibbs phenomenon was disappearing. So but this is an interesting point. So thank you. Yeah.
Okay, so if no other questions, we thank you, the speaker. And now, Giulio.
Sì.
Senti, io direi se puoi parlare te adesso, perché Ivan si è perso per strada, forse.
Va bene.
Perché se no...
Va bene, non c'è problema. Ho anche scritto un'email a quella che doveva presentare l'altro articolo, ma dubito che arrivi, francamente.
Ma come mai? Dove è? Vabbè.
Non lo so, non si è ancora connessa, quindi...
Vabbè. Cioè, tu hai scritto un'email?
Sì.
Ok. Vabbè. È l'unico modo che abbiamo per rintracciarla, giusto?
Beh, io credo di sì. Non so se ci sia un altro modo, ma eventualmente quello dovrebbero pensarci o Damiano o il professor Gervasi, perché io i contatti non riesco a vederli. Eventuali altri contatti, vedo solo una mail pubblicata nell'articolo.
Va bene. Allora, sei d'accordo che parli te adesso?
Va benissimo, sì.
Come può andare bene?
Sì.
Ok.
Ok. Allora, un attimo solo. Ok, vi chiedo un feedback se riuscite a vedere le slide.
Sì, vedo.
Ah, perfetto, grazie.
Aspetta un attimo, Giulio.
Sì, datemi voi il via.
Sì, infatti. Okay, so the next speaker is Professor Giulio Biondi, and he will speak about quadratically transformed luminance chrominance spaces. Okay, Giulio, puoi andare.
Okay, so thank you, Professor Vinti, and I'm glad to participate in the first edition of this interesting workshop. So today we will be talking about color spaces and uniformity. So we developed some new color spaces which have some interesting properties, and we tested them for the defading image problem. For this purpose, we also developed a two-step defading approach, which delivers good results and is simpler than other approaches. So let's start with the first topic, color spaces. So there are several color spaces defined in literature, but not all of them present the property of uniformity. So in uniform color spaces, close colors are perceived as similar by the human eye. So colors which are close in a geometrical sense inside the color space are also perceived as similar, and color gradients are smoother than in non-uniform color spaces. So common color spaces such as RGB and CMYK are not uniform, as we can see, for example, in the first picture on the right, where we show the Adobe RGB spaces. The gradients are not all smooth. And there are also other spaces which are uniform. The most famous one is the CIE-LAB space. So they are uniform, but they usually present difficult transforms from the RGB space, for example. In the second picture here, we can see a slice of the CIE-LAB space. And we see that all the gradients are pretty smooth if compared to the other one. The goal of our work is to define new uniform color spaces which use quadratic transforms and numerical coefficients. So they somehow present both properties, a simple transform from the RGB space and uniformity. Uniform spaces are usually defined in terms of luminance and chrominance as 3D spaces, presenting a luminance component and two chrominance components. So the luminance component usually has to do with image details. So in defining the borders of the object, as you can see in this picture. The picture on the right represents the luminance component for the image, the original image on the left, using the three spaces we defined that I'm going to show later. The chrominance components instead have to do with color stains. As you can see, there are no sharp borders in the image, but rather patches of colors. And as you can see on the left, we have the two components, usually called alpha and beta, and the total chrominance component on the right. This is made using the QTLC R star G star space, which is one of the three spaces we've developed. We start by mapping a color in the Adobe RGB space, which has three coordinates in the range 0, 1, to another space with 3 coordinates, in which we define the L coordinate as the luminance, with 3 coefficients adding up to 1, and the G component, the green component, predominant, since the human eye perceives the green component as predominant, and 2 more coordinates, R star and G star. As a second step, we define another mapping from the previous coordinates into 3 new spaces, which we call QTLC, R squared, G squared, and RG, which map primary colors in such a way that all 3 spaces map them in the -1, 0 point for the aqua green color, 0, -1 for the blue color, and 1, 0 for the magenta color, and the gray color in the origin of the space. This is a slice for a set value of luminance of the 3 spaces, along with the CIE LAB space, for a comparable amount of luminance. We can see that the first space, R2 star, presents in the upper right section a sharp gradient between the red, yellow, and orange colors. On the right upper side, we see that the G squared star space presents a compenetration between the blue and the magenta section of the space. The best looking results are those of the R star G star space, where we see that all the gradients are pretty smooth and there is no compenetration. For a similar amount of luminance, we can see that the CIE space has colors which are less vibrant, since more vibrant colors are reserved just to the end of the luminance component. As we will see, the R star G star space is the one that delivers the best results in the image defading problem, which consists in estimating the ideal image source given a faded image. Images fade over time and lose quality and detail. So the contrast lowers, details are less sharp, and colors are less vibrant, usually. The 2 classes of restoration methods are, of course, digital methods and physical methods. The obvious advantages of digital reconstruction are those that are listed here. So speed, flexibility, reproduction, accessibility and preservation, and most non-invasivity. So many trials can be performed without compromising the original faded image. We define the image defading problem as a 2-step problem, in which first we deal with the luminance and then with the chrominance components in 2 separate phases, which are almost independent. The first problem is that of restoring the luminance. So the direct problem is to calculate the observed luminance in terms of the ideal luminance, some additive noise, which has some specific properties, and a blur matrix, which should describe the blurring process of the image. Of course, we want to solve the inverse problem. So finding an estimation of the original luminance, given the observed luminance, the blur matrix, which in our case is defined experimentally, and the noise variance, sigma squared. For this purpose, we define an energy function which has to be minimized to achieve a satisfying solution of the problem. We employ regularization techniques for the luminance function, which is a piecewise linear function. And we also employ some additional line variables, which are meant to deal with discontinuities in the image. So in the luminance component, which, as we saw before, has to deal with image details, discontinuities represents borders between different objects in the image. And so considering line variables allows us to better sharpen the borders between objects and obtain, in the end, a more defined image. So the energy function is composed of these three components. One, which is the solution faithfulness to the original image, of course, the regularization term for the piecewise linear function, and an epsilon component, which is meant to avoid parallel discontinuities. So to avoid having close parallel borders, which do not deliver sharp borders in the final image. The importance of the epsilon term can be seen in this slide. So for the same blurred image, which we see on the upper left corner, we can have two reconstructions, which are somehow similar to the human eye, but the underlying quality of the reconstruction is much better for the upper right one rather than for the center one, because there are far less parallel discontinuities in the line plot, which you can see on the bottom section of the slide. So the use of the epsilon term allows for a better reconstruction. As for the chrominance deblurring part, it is of course divided in two parts, one for the alpha and one for the beta component of the chrominance. We employ the same matrix as in the luminance step, because we experimentally saw that the results are consistent this way. And two terms, N alpha and N beta, which represent additive white noise in the image with the following characteristics. So white Gaussian noise with zero mean and sigma squared variance. Also, in this case, we aim at minimizing the following energy function, in which we have the first two terms representing the faithfulness of the solution to the original alpha and beta component. And also here a regularization term. The difference is that here we consider differences only of the first order, while in the luminance step, we considered differences of the second order, while the line variables, W, are the same ones as in the previous step. We will now show some samples of reconstructions using the free spaces and focus on the details to show that the QTLC R star G star is our choice for future experiments. So this is the first sample image, in which you can see that over time the colors turn to have a red shade, which is common with old photographs. And this is the reconstruction obtained with the R star squared space. Following, we have another image suffering from the same problem as the previous one. Those are streets of the city of Livorno, and as you can judge from the cars, are 40 or 50 years old images. And this is the reconstruction using the G star squared space. As you can see, the colors are more realistic and have lost its reddish shade all over the image. This is yet another sample image on which we will focus also later. And this is the reconstruction with the R-star G-star space. We can see that colors are more realistic in this one and details are sharper. This is another example of the same image reconstructed with the all the free spaces defined in our work. Sorry for the typo. Of course, the left one is the R-star squared space. And we will focus on two details of the image. For the R-star squared space, we can see that the bridge assumes a more vivid red color, which is less realistic than the one obtained with the R-star G-star space. And instead, focusing on the water, we can see that with the G-star squared space, the water assumes an electric blue color, which is, of course, unrealistic, while it has a more natural tone for the R-star G-star space on the right side of the slide. In conclusion, so we defined three new uniform color spaces defined in terms of luminance and two chrominance components. And we tested the new spaces for the image defading problem. For this purpose, we defined also a new two-step technique, which uses second-order discontinuities differences for the luminance component and first-order for the chrominance components. So this is the end of the presentation. Thank you for your attention. And should you have any question, you can address them to me or to Professors Boccuto and Gerace. Thank you.
Okay, so thanks to the speaker for your interesting talk. Are there any questions or remarks?
Okay, I can one.
Okay.
The question is, how did you select the coefficients for the transformation? So I saw these several coefficients, but it was not clear to me how you define this transformation. So why you selected this transformation? You selected because it has the good properties that you want to have, or is there any other property that you use?
Could you please repeat, because I couldn't hear?
Okay, in one of the first slides, you have shown the transformation that you use to generate the new color space. Okay, it has several coefficients for the different parameters, elements. And so, how did you select it? How they had been selected? Why did you use those coefficients instead of others? And
Okay, thank you for the question. So I'm sure later Professor Gerace could also help you more with the question, but first let me get back to the slide and tell you. So this is the first phase of the color mapping, as we saw, and this is the second phase.
Giulio, sorry,
See?
Giulio. Can you share the slide?
Oh, I'm sorry.
We do not see.
I forgot it wasn't sharing anymore.
Okay, now it's okay.
I guess. Yeah, so the coefficients were shown this way. So first, the idea was to have a quadratic transformation from the RGB space to the new spaces. So then we had to find coefficients which mapped the side colors, as I show in the picture in the lower section of the slide, in this point, in these specific points. So the coefficients are chosen to map those specific colors in these specific points. That's the main reason for choosing these coefficients. Also in the paper, you will find the mapping of the colors, of the specific colors in the points, a table with all the mappings. So the choice of the coefficients is done in this way.
Okay.
Any other question?
I have another curiosity.
Okay.
If the examples you have shown are real pictures you have taken, and or they are creating included set some varied on these pictures. So are pictures taken of real images or not?
Yeah, so pictures were downloaded from the internet and they represent real images. So they weren't first blurred or stained and then reconstructed. And that's why also we cannot show, let's say, a numerical assessment of the quality of the solution, but we present visual assessments because we do not have the original image available, but only the faded one. But they are real images, yes.
Thank you.
Okay, and I have a question. Can you do a kind of a comparison between this method? A kind of a...
well, we could do if we focus on images of which we have the original version. Then we apply some kind of artificial blurring, and then we reconstruct them back using the spaces we defined and perhaps other spaces in literature. For these preliminary experiments, as I was saying before, we do not have the original image, so I'm not sure if any numerical comparison between the three spaces can be provided, let's say. But for sure, it would be interesting to have some kind of measurement in future experiments.
Okay. Okay, thanks. And
Thank you.
if there are not any other questions, we thanks again the speaker. Thank you.
Thank you. Thank you to everybody.
Okay, next speaker is Ivan Gerace, and he will speak about blind source separation of color, noisy, blurred images.
Professor Vinti, I think we had made a swap, but Ivan is going to present in the afternoon, I guess, and now it's time for Tala, because otherwise there wouldn't be time left, I guess.
Do you agree?
Because there is just one slot left for the break.
Okay, okay, okay. So Professor Tala Mahmood is online.
Hello, everyone. I will be going to present the paper. Am I audible?
Okay, sorry, Professor Tala Mahmood.
No, this is, I will be presenting, my name is Syed Mohammad Hassi. I will be presenting the paper. Am I audible?
Yeah, we can hear you.
Okay.
Yes, yes.
Great. Okay, I'm sharing my screen.
He will speak about fluid fly detection and classification in IoT setup.
Yes, sir. Is my screen visible?
Giulio?
Sì?
Possiamo vederlo? Il professore che parla?
Io riesco a vedere. Sì, sì, si riesce a vedere. So we can see your screen. It is sharing properly.
Okay.
Noi non lo vediamo.
So,
please wait 1 second.
sure.
We are having some technical problems.
Ma è entrato?
Sì, sì, sto parlando. Penso che sia chi è? Tala?
No.
SM.
Sied.
Siem.
Yeah.
Okay, here. Okay.
Non sai cosa dopo, pensavo di recuperare il copyright. Vabbè, lasciamo così. Lui parla del pomeriggio, ma il pomeriggio ci sarà lo stesso problema. Pomeriggio, infatti, dura esattamente quanto.
Okay. Hi, I'm sorry. Your camera is open. Eh? È la sua videocamera.
Excuse me?
Yes, yes.
Your camera is over. Can you open the camera?
Sure, sure.
Forse se condivide non lo vediamo.
Non si dovrebbe vedersi un pallino, come Giulio prima, no?
Sì.
Giulio vedi condivideva e poi si vedeva anche lui. Vedi? Il pallino dovrebbe vedersi, non si vede. Vabbè, non lo vediamo. Niente.
Io riesco a vederlo. Prova
Okay, now.
a cliccare.
Ok,
ok.
Now we see. Then try to share the slide.
Okay,
Yes.
Okay,
Okay,
fine.
perfect.
So,
Thank
is
you.
it visible?
Okay,
Now
very
yes, I guess.
good.
So, should I start now?
Okay, you can start.
Okay, sure. Okay, good morning, everyone. The title for my conference paper is Fruit Flies Detection and Classification in IoT Setup. My co-author, my name is Fasi. I'm the first one in the authors, and my co-authors are Asad Ali, Talham Abu Datif, Muhammad Hanif, and Waqar Ahmed. Okay. The main problem statement for the paper was that we are targeting the fruit flies that harm our agriculture, in a very significant manner. So they are the most dangerous pests which cause damage to crops and affect the economy worldwide. So we thought of a real-time IoT-based detection system that classifies the fruit flies that is based on a deep learning approach, so that we could identify that which types of and how many fruit flies are there that are attacking the plants or the orchards or the fruit farms. Okay, so that was the main problem, the idea for developing that deep learning system. Moving on, we did some literature review for the paper initially, and we found out many people have used various techniques such as different types of, for example, classical machine learning algorithms that are using, for example, thresholding techniques or segmentation or there are various techniques, and they are using different types of sensors and different types of cameras or traps, and they are trying to do the same thing. And we targeted the same thing using real-time camera feed and deep learning for the detection of fruit flies. The main problem was that using these classical algorithms, they had some human error in counting the fruit flies, in detecting the fruit flies. They did not reach that potential. And we tried to maximize that potential. And we also enabled real-time detection and classification. Okay. Moving on, these are all the papers we have gone through, and they have, for example, the last one for the fruit flies is about modified traps with optoelectronic sensors. People have done that with that. We used just simple camera systems for that. And for example, they used the techniques such as sport vector machines or classifiers or different types of other techniques. Deep learning. So why did we go for the deep learning? Deep learning basically was a technique that can basically learn patterns given input. In our case, the input were images. So as the amount of data increases, the algorithm becomes more good at recognizing the hidden patterns among the data. So we thought, why not doing that thing and doing it in the real time on a very resource constrained system, an IoT system, AI-based IoT system. So what we did was we deployed the deep learning algorithm to detect and classify the fruit flies on the sticky pad using an IoT system. Okay, the main YOLO, we used the YOLO architecture, and the methodology we followed is slightly different from the existing YOLO architectures, because we had to optimize our algorithm for that small flies detection. So we had to optimize it for the small object detection so that it could recognize like small objects in the frame. So we introduced a new approach that would tackle the problem of low inference speeds on IoT devices. We used the IoT device NVIDIA Jetson Nano for our purpose. Okay, so we proposed some modifications to the existing YOLO version 5 architecture so that it can achieve superior results on small objects while significantly reducing the floating point operations, which is actually a measure of the computational complexity of the algorithm. Therefore, we are like able to deploy it on a very resource constrained system such as an IoT device like at NVIDIA's Jetson Nano, where we have very limited memory. So how did we do that? Was that we replaced the standard convolution operation with a ghosted convolution operation. This is actually the paper that was called GhostNet. We took the idea from that and we replaced the standard convolution operation in the YOLO version 5 and replaced it with that ghosted convolution. And then after that, we replaced it with the ghosted convolution. We were able to lower the floating point operations significantly. And more than that, we changed the deep learning, the architecture of the YOLO version 5 at the backbone level, which is basically the CNN part. And we also changed at the prediction level or okay. So there are actually 3 prediction levels in the YOLO version 5, small, medium, and large. So we did not require the large. So we removed the large and we used the small and the medium. So a fly can sometimes have a slightly bigger size or it can have smaller size. So we used these 2 prediction levels. We discarded the 3rd prediction level. So this also further reduced the complexity of the algorithm as well. And then the diagram of the very general diagram of the YOLO version 5 is as shown. It consisted of like 22 layers, and we have series of ghosted convolution layers forming the backbone. And then we have these 2 prediction heads, which are actually not shown here, but we have these 2 prediction heads that best suits to our case. Okay, deploying the convolutional neural networks on embedded devices limited, as I said earlier, that's due to limited memory and computational resources. Okay, the main problem with the standard convolutions is that when we generate the feature maps have a lot of redundancy within the feature maps. So these redundancy is just waste and causes overfitting problem. So we have to avoid this problem. So for that, we opted for the GhostNet, and so that we can reduce the redundancy in the feature maps, and therefore we can enhance our precision and accuracy. So therefore, we also are basically lowering the overfitting of our algorithm on the data set. So basically, the idea of the GhostNet is to compute a series of linear transformations that can help generate some ghosted feature maps. It's basically a projection of some feature maps that could fully reveal the information underlying the feature maps, the input feature maps. So how actually this ghost network is like, we have this input. We split the input into two parts called the intrinsic feature maps and the extrinsic feature maps. We keep the intrinsic feature maps and then we apply the ghosted convolution on the extrinsic feature maps. So basically we're doing a 50% standard convolution, then we remove the 50%, then on the other 50%, the extrinsic feature maps, we are applying some linear transformations to get the projections of we were basically using projections to produce the feature maps that do not contain or that have minimum redundancy. So the main idea is this behind the ghost net. So it's just like that. We run a quick linear operations to approximate the rest of the ghosted feature maps, and then we reduce the computations because we are actually only performing 50% real standard convolutions. The rest 50% is actually some linear combinations to produce the projections or the ghosted versions of those feature maps. So since we are also reducing redundancy, so overfitting is also being reduced. So it has a similar effect of applying regularization. So we can also remove or eliminate the regularization terms within the algorithm, because this is already giving us that regularization effect. And then this was for the backbone, how the convolution was done. And then at the detection part or the detection head, we had made some modifications at the prediction level. As I said earlier, we have removed actually in YOLO we have 3 detection heads: the small, medium, and large. We removed the large and we kept the medium and the small. So by keeping these two, we are basically, first of all, we're basically reducing some computational complexity of the algorithm, because we're reducing some part of that, we are removing it. And then for the small and the medium, we have this grid size, which is, for example, 8 by 8 as shown in the diagram, 8 cross 8, and then we have this 16 cross 16. 8 cross 8 is for that medium detection. As you can see, the boxes size are slightly bigger. And for the small grid size, for the 16 cross 16, we have this very small. You can see we can actually very well fit the fruit flies within the box. And then within using this grid size or grid cells, the algorithm fits an anchor on them, and then we can do a prediction. These are like, in the next part, we have these anchors that the algorithm suggests, and then based on the anchors, we come up with this detection and classification results. Okay, so as far as comparison is concerned, for comparison of our version, which we call a YOLO version 5 FlyEye, with some other versions of the YOLO algorithm, which is a version 5S and version 5N. So we are comparing our algorithm against these two algorithms that is already given by the YOLO repository. Okay, results. The following, the results we are showing is for the floating point operations versus the overall mean average precision at 0.5 to 0.95 IOU, intersection over union. So as the bar graph shows, is that our YOLO version 5 FlyEye slightly outperforms the existing version 5N and version 5S in terms of overall mean average precision. And it has also lower floating point operations than these both version 5N and version 5S. So this is one of the major things we've done in terms of results. And then next we have is a graph of the epochs versus precision. Considering that the hyperparameters for the all 3 algorithms while training remained constant or were the same. So we have this version 5N, version 5 FlyEye, and then V5S. As you can see in the graph that the version 5 FlyEye this red one took lesser number of epochs and is slightly gives slightly higher precision as well. Okay, these were the training parameters as described as shown in the table. Then we have some comparison that shows that which GPU we have used while training these algorithms, and then the weight file sizes, how small the weight file size is, because we have resource constrained system, so we would require a file size that is so smaller. So we have also achieved that while we also have significantly lower floating point operations in comparison to both YOLO version 5N and version 5S. These were some of the detection results we have achieved. And in conclusion, I can say is that this results actually show a significant potential in AI-based systems and devices based on resource-constrained systems that can be deployed in the agriculture sector. And for example, like on embedded systems like NVIDIA Jetson Nano, proposed improvements can achieve good results in detecting and classifying these fruit flies. So we aimed to lower the computational complexity and a much more optimized version of that deep learning algorithm. So hope that this further improves the agricultural sector in terms of modernization, lowering the loss of fruits and etc. These were some of the references we have found. And any questions anyone has?
Okay, so we thank the speaker. Are there any questions, remarks?
I have one question. So you evaluated the precision of the method. Okay. Did you also computed the recall of the method? So how many flyers the technique is able to
so you're basically asking for the recall, that we have computed the recall or not. Is that what you're asking?
Yes, exactly. Yes.
Okay, so basically we do have computed the recall, and recall was around 0.91, around 0.91.
Okay.
Yes.
And I have also another question. So how this method is targeted to a specific the method?
I couldn't hear you.
I can try to speak louder. The method is used for specific flyers. It is easy to adapt to other types of.
Yes. Yes, we can easily adapt. The algorithm can easily adapt to other types of flies as well. Yes.
So can you estimate the cost of this adaptation? So how it takes in terms of work to be done? So it's easy, but how much is?
Sorry, I cannot hear this. The last part you said.
Yes, sure. Can you estimate how easy it is? So easy, but
what did you said? How easy?
Suppose that I want to adapt it to a new type of fly. How much work I have to do that?
How much work?
Yeah, it takes 1 hour for one person, or it takes 1 month for 10 persons. So it's just an estimation of the cost.
Like to label the images? How much time it takes to label those images?
Yeah,
you're asking that?
Yes, exactly. How much?
Okay, so basically, the amount of time it can take significant time to label the images, because it has to be done manually. It depends on how large the data set is. So, for example, we had like around 3,000 to 4,000 images, I believe. So it took us so we divided in between like the authors, so everyone did their part, and it took like around a week or so, gradually doing it, labeling. So
So you require 3,000 or 4,000 images to be.
Yes. For example, we had around 3,000 to 4,000 images. So it took us around a week. So like we were doing it at our like comfort whenever we had time. So we took a week to label those images.
Thank you.
Okay, are there any other question? Okay, if not, we thank again the speaker.
No, thank you so much, everyone.
Okay.
Thank you so much.
This part of the section is over, and we meet again in the afternoon after the plenary lecture, 15:30, in classroom I. Classroom I is when you exit from here, the building down, you just take the stairs and you follow the circular wall, okay? And you find a door on the right. You enter there, and there is the classroom I try to explain because it is not easy.
Good luck.
Okay, and good luck. Yes. Okay, see you later. Thanks to all the speakers, and we meet again later. Questo lo troviamo anche nell'aula.
Cosa? Mi sembra di sì. Sì, dovrebbe esserci uno nell'immediato.
Quindi non lo prendo.
In caso se se lo vuole prendere.
Però, vabbè.
Sì, sì, sì. In caso manca per errore. Allora, qui ci sono ancora quelli, in realtà quelli della scorsa sessione.
Ok, praticamente. E quando poi devo presentare io, perché alla fine devo fare anche una presentazione, quindi per passare poi diciamo alla schermata.
Allora, praticamente come funziona? Allora, io ho messo questa cartella qui, si chiama 4 luglio. 4 luglio. Poi ora stoppo la presentazione qua, tipo vedi, stop sharing. E una volta che carichi la presentazione qui, vai di nuovo su Jitsi, fai condividi schermo, application window e prendi la tua presentazione. Ok?
Dico, la modalità classica di condivisione.
Sì, sì. Basta.
Dalla schermata di
E sessione di Essimo adesso. Ok.
Sì, però per andare un attimo nelle cartelle. Non so se è quella però. Cioè all'interno della. No, non è questa. Ce l'ho nella cartella.
Non si capisce niente. Hai il computer qua?
Perché così?
Non lo legge. Aspetta che provo a staccarla violentemente. Sembra che si sia tipo resettata.
Vabbè, provo.
Aspetta un attimo. No, è come se si fosse bruciata la pennetta. Hai il computer? Ce l'hai sul computer? Ok, e ti do la chiavetta, ce l'hai la borsa fissa? Dentro c'è una chiavetta. Perfetto.
Andiamo a tolgo. Devo usare come
Sì, sì, certo. Certo.
Oh, va fa niente. Fammelo uscire. Ok. Posso togliere? Il microfono è sempre acceso. Sì. Ok. E poi condividono il numero in automatico. Quando devono condividere fanno il numero in automatico.
Sì, da remoto volevo condividere, sì.
Ok.
Ho toccato la presentazione qui, riesco condividere.
Okay. So, good morning to everyone. This is the Socioeconomic and Environmental Models for Land Use Management workshop. And this is the first session of this workshop. The second one is will be held in the afternoon at 5:30. And in this session, there will be discussed 5 papers presentation. The main topics, the main research topics that will be addressed varies from the student housing, the real estate risk assessment, the social discount rate assessment, the endogenous and exogenous leadership teamwork factors, and the Airbnb phenomenon impacts on the rental market. The questions about presentation will all be made at the last turn, about 5 minutes of the session. And the fourth work, the work a logical perequative methodology to define the social discount rate for the cost benefit analysis application, is moved to the end. So the final order of the presentation will be, first of all, the papers carried out by Tajani, Manganelli, Cerullo, Morano, Arenas, Morente. The second one will be Morano, Anelli, Tajani, Roma. The third one will be Michel, Paredes, Leon, Tapias, and Calle. The fourth one will be De Paola, Iannitti, Manganelli, Del Giudice. And the last one will be Di Liddo, Anelli, Morano, Tajani, Torre. So we can start with the first presentation. So the paper carried out by Tajani, Manganelli, Cerullo, Morano, Arenas, Morente. So
Each presentation has about 15 minutes, at least not more than 5 minutes. Okay, so the first paper, if is here,
Good morning.
Can share. Good morning. Can share the screen for your presentation, please?
Yes. Mm-hmm. Can you see my screen?
Yes.
Okay. Good morning, everybody. I am Giuseppe Cerullo, and this presentation is about the importance of student housing development as a significant growth area and a valuable means of revitalizing existing real estate assets. It emphasizes the economic benefit and the positive environmental impact that such a development can have on surrounding area. A specific case study of innovation of an existing building will be presented, focusing especially on the city of Perugia. The study discusses the definition of the objective, contextualizing the research within a reference framework, providing a global overview before focus on the Italian context. A specific case study is introduced to illustrate a practical application and the obtained results. Finally, the study provides a conclusion and outline future research development. This research aim is to analyze the main aspect related to the student house sector, with a particular emphasis on the development of a business plan that play a crucial role in achieving economic return for a private investor. The objective is to carefully examine the key elements that influence the effectiveness and the profitability of investment in the student house sector, evaluating market opportunities, demand and supply dynamic, as well as financial and managerial aspects that contribute to the success of such a business plan. In recent years, the student house sector has obtained significant attention, becoming a focal point for investors. Globally, the investment in this asset class reached $70.7 billion in 2019, making the fourth consecutive year in which volume exceeded the $16 billion. Another factor that makes student housing an attractive asset class is its high yield. Additionally, the resilience of the student house sector during recessionary phases is highlighted by its low risk compared to other types of assets. The growth in demand for student housing in Europe has been influenced by various factors. For example, the increase in the young population and the exchange program like Erasmus. Recently, there has been relevant development in the student house sector in Europe as well, with an estimated investment of around 9 billion euros in the past year. The numbers related to the student house sector in Italy are extremely enticing and make it difficult for an investor not to get involved. In Italy, in fact, 98 universities, with 10 of them ranking among the top 500 universities in the world. In between 2015 and 2021, there has been a steady growth in the number of out-of-town students. However, this growth in demand for student housing is in stark contrast to the structural shortage of available bed space. Currently, only 12% of the total required bed space are covered, and only around 30% of eligible students can actually access the student housing. Student residential offering and young workers in the national territory can be divided in two main categories: public and private supply. The institutional supply, so public supply, consists of real estate product managed by affiliate entity and provide housing solution aimed at the specific segment of the demand, characterized by well-defined socioeconomic requirements and academic merit. Filling the gap left by private affiliated entity is the market for private rental, which face strong pressure, leading to evident negative effect on the student. They often fall victim to systematic speculation that has developed around the rental market, resulting in imbalance within the urban fabric. The research work has been developed considering the following initial condition, as highlighted by the reference framework. There is a steady increase in the number of out-of-town students that is not matched by an adequate housing supply. In this regard, key aspects of managing university housing initiative are investigated, analyzing cost and revenue components, also based on the application of numerous tax incentives, in particular the financial incentive promoted by the National Recovery and Resilience Plan. This case study has been organized into 4 phases, defined as follows, and will be briefly discussed in the upcoming slide. The focus on the first phase is on a building situated in the central area of the municipality of Perugia. The building primarily serves office purpose and is currently unoccupied. It contains 5 floors above street level and 2 floors below street level, interconnected by an internal staircase and elevator. From an urban planning standpoint, the building's location is well suited for a transformative project aimed at rehabilitation and refurbishment of the structure to accommodate the student housing. In the second phase, we analyze the demand and the supply in the city of Perugia. It is evident that there has been a 45% increase in the number of university students compared to the previous year, with a notable 1.8% specifically among out-of-town students. However, the significant growth in demand is met with a significant decrease in supply, leading to a gradual and a constant increase in price. In the third phase, the architectural redevelopment project of the building and the study is presented, transforming it into student housing. This project has been conceived following a thorough analysis of the study area and the building structure. Inside the new building, there are 140 rooms organized in the hotel type using housing units. Each unit accommodates 1 or at most 2 individuals. In the fourth phase, the evaluation of the enhancement investment on the compendium and the study has been developed, borrowing the discounted cash flow analysis technique. In this case, the cash flow analysis has been evaluated over a long period of 21 years, aiming to allow for a return on investment. In the initial part, there are the fixed costs incurred by the property, which are divided in the following elements: administrative expenses, reserve for extraordinary maintenance, property insurance, property tax, registration tax for the lease contract, and the lease commission. Regarding construction costs, which have been divided into categories: hard costs and soft costs. The hard costs are costs directly related to the physical construction of a building. For hard cost was evaluated a parametric cost of 683 euros per meter square, inferred from the price list. Instead, soft costs include design and construction management costs. In addition, there are additional specific costs, such as urbanization charge. These costs included 2 portions, which are determined according to the municipality's resolution. And finally, contingency. This element represents 5% of the amount related to direct construction costs, and is intended to cover any unforeseen contingency or changes in cost during the construction phase. Or operation cost, which can vary significantly depending on the scope and the quality of the service provided. In the scenario under examination, they include in the cleaning of common area and rooms, bed line change, reception service, and maintenance of garden. This cost, this service are estimated to be equal to 210,000 euros per year. It is essential to recognize that the implementation of measures aimed at promoting student accountability and adherence to established protocol can result in a significant reduction of operation cost. In order to estimate the monthly price of the single and double room, a pluriparametric estimation process, known as the sales comparison approach, this method takes into account various variables believed to influence the price of a property. It involves adjusting price based on the characteristics of a comparable property and property being evaluated. The differentiated factor and their corresponding adjustment percentage are presented in the table. The management revenue primarily consists of income derived from long-term lease rental during the autumn and winter, as well as short-term lease rental during the summer season. There are also expected to be additional revenue from the ancillary section, which represent a marginal share of the total revenue. Furthermore, the terminal value has been calculated, representing the value of the business at time of sale, or a final value with the ability of the business to generate cash flow beyond the forecast made. This terminal value is estimated to approximately 40 million euros. We can see that the net present value of the investment before taxes is positive, amounting to 2,102,000 euros. The post-tax net present value, estimated by considering taxes of approximately 30% on the positive cash flow, is equal to 107,000 euros, and the corresponding internal rate of return is equal to 16.66%. As the net present value is higher than zero, and the rate of return exceeded the established threshold, that is the discounted rate used for the information of the discount cash flow analysis. So the project is financially viable. Finally, thanks to the fund located by the PNR, it is now possible to concretely consider the recovery of existing real estate heritage, also favored by the strong involvement of the private sector. In this perspective, the case study of the construction of a new university residence that involves the recovery and enhancement of an abandoned building has been dealt with. In addition to generating a positive environmental impact on the intervention context, this operation also entails an appropriate earning for the investor that has been specifically assessed. So, starting from student housing as an asset class with a strong social vocation, putting young people and their future at the center, creating sustainable residence from an environmental, social, and economic point of view, thanks also to the research allocated by the PNR, are the springboard toward a radically different housing future for students who live away from home. The challenge is to combine the quality of design with the financial convenience by developing a new culture of design and construction of this structure that pursues to seek innovation solution, does not flatten out on housing container, and is able to generate win-win initiative from an environmental, social, and economic point of view. Thank you for your attention.
Okay, thank you, and thank you also for the clear presentation, and also to be in time. Thank you so much. And the topic is really interesting. So if at the end of the session will be some observation, comments, or question, keep in touch. Okay. So we can move on to the second paper's presentation, the ones carried out by Morano, Anelli, Tajani, and Roma.
Good morning.
Morning. Can you share the screen?
Yes.
Thank you.
Can you see?
Yes. Okay.
Today I'll present the research titled The Real Estate Risk Assessment, an Innovative Methodology for Supporting Public and Private Subjects Involved into Sustainable Urban Interventions, carried out with Professors Pierluigi Morano, Deborah Anelli, and Francesco Tajani. The presentation is structured into 5 sections: aim of the work, framework of the research, description of the assessment model and case study application, result discussion, conclusion, and future insights. The aim of the work is the definition of an ex-ante risk assessment model that can support the public administration and private entrepreneur involved into public and private partnership urban transformation intervention through the determination of a composite indicator, the Real Estate Risk Index, IRER. The proposed methodology is able to assess the level of the real estate risk that pertains to a specific territorial scale chosen for the analysis. The proposed methodology is suitable for any special context, for any different type of urban redevelopment intervention, land use, and is able to represent baseline risk, taking into account local market condition, spatial scale, and generic project. In particular, the proposed model aims to support the public administration and the private entrepreneur by carrying out a classification of urban areas according to risk levels, allowing the identification of both the most critical and the most profitable urban areas, supporting the public administration in choosing the most suitable type of private contractor to be involved based on the risk-return profile, to carry out successful redevelopment processes, definition of urban planning parameters on which the financial convenience of the entities during the negotiation phases depends, the possibility of giving the private entrepreneur a primary idea of the basic risk they have to face, to which additional risks related to advanced stages of projects should be added and considered. From a methodological point of view, the proposed innovative model integrates the multi-criteria technique, indicator system, and geographic information system to create a semi-quantitative ex-ante risk assessment model to support the decision of operators involved in operations. The model uses the multidimensional management ability and flexibility of the analytic hierarchy process to structure a set of quantitative and qualitative risk indicators and to aggregate them into the final proposed risk index. Urban regeneration processes represent an important strategy to be carried out for the realization of resilient urban paradigms. Due to the scarcity of financial resources that characterize public administration, urban transformation processes are often implemented through partnership between public entity and private entrepreneur. One of the main advantages of public-private partnership form is the possibility of sharing the benefits, but especially the risks associated with the implementation of urban transformation project. However, the uncertainty that characterizes the current historical period makes the assessment of property risk by stakeholders complex. Real estate development intervention may be affected by 2 different types of risk: systematic risk and non-systematic risk. Systematic risk is connected to factors linked to the trend of global financial markets and to socioeconomic factors and affects all types of investment. Non-systematic risk is closely related to the project. In particular, different types of risk may affect the different stages of project implementation. In this context, Due to the variability of risks associated with the implementation of redevelopment projects, there is no consolidated framework for identifying each of the many different types of risk. The need for operators to use effective tools and support decision-making processes leads to the development of this real estate risk assessment model. The proposed model is structured into the framework shown in this figure that consists of 10 phases, which lead the elaboration of the real estate risk index. The case study of the present research is the city of Rome, capital of Italy. The vastness of cultural real estate, in fact, represents one of the main risk factors because it is able by itself to not only slow down the process of realization of the urban intervention, but in some cases, even to stop it, with consequent losses of revenues and capital. This phase consists in the definition of the practical implication that the obtained risk index could provide for the public and private subjects involved. The risk index should make it possible to adjust the parameters on which the convenience of the project for the parties involved depends. In the case study, the main end user of the index is mainly generic private entrepreneur. For this reason, it is necessary to know the general condition of the real estate markets of the established target sector. This goal is possible through an in-depth analysis aimed at understanding the main types of risk to be taken into account. After examining the case study and with the aim of achieving the objective defined in relation to the risk index, the specific risks considered are market risk, context risk, and insolvency risk. The ISRR is calculated as a weighted sum of these three types of specific risk. The territorial scale for which the index is calculated must pertain to the effective utility of the final user. It could range from the national to the sub-municipal one, passing through the regional, provincial, and municipal. In the case study, the sub-municipal territorial scale is considered the most suitable one. For the city of Rome, the sub-municipal scale refers to the 234 perimeters of the municipal area carried out by the Real Estate Market Observatory of the Revenue Agency for the year 2020. The OMI zones are identified according to characteristics of homogeneity from an urban planning point of view and the dynamics of the local real estate market. 213 out of the 234 OMI zones of the city of Rome are considered as the territorial unit of investigation used for the purposes of this research. In this phase, it is essential the analysis of the local real estate dynamics for understanding what are the most suitable indicators able to represent each of the three types of specific risk considered. In the context of the case study analyzed, the identification of indicators was carried out by analyzing documents and reports on real estate market dynamics, comparisons with the real estate agents operating in the Rome real estate market, and local professionals. The initial set of indicators comprises a total of 24 items, of which 14 refers to the market risk, 5 to context risk, and 5 to insolvency risk. There is a difference in set of indicators collected in terms of data measurement methods. A data normalization operation is essential to eliminate differences in measurement units and to subsequently compare and aggregate the indicators into the final risk index. In the context of the case study, the min-max technique was identified as the most appropriate for achieving and meeting the set goals. The correlation analysis is required for eliminating the indicators with high overlapping of data in order to obtain a more robust and efficient real estate risk index. The correlation levels are checked by analyzing the Pearson coefficient among the 24 normalized indicators. The final set of elementary indicators for the construction of the proposed risk index, after having carried out the correlation analysis, is composed of 17 indicators, of which 8 for market risk, 5 for context risk, and 4 for insolvency one. In this phase, the identification of the ranges of variation of the values of the indicators on the totality of the omit zones is carried out. It is necessary to determine the importance in terms of local weight of all the factors that constitute the structure of the AHP, in order to take into account each factor considered in the formation of property risk. A total of 20 pairwise comparison matrices were constituted. The consistency of each matrix is always checked by calculating the consistency index. The aggregation of indicators through the implementation of a weighted sum model allows the determination of the risk index. Specifically, the proposed methodology involves the adoption of the following formula for determining the level of property risk related to the territorial units under analysis. Sensitivity analysis can help assess the robustness of the proposed risk index, increase its transparency, and help frame the debate about it. For this reason, in this phase, weights of the market, context, and insolvency risk indicators were varied based on 3 possible scenarios. Market risk is more important than context and insolvency risk. Context risk is more important than the market and insolvency risk. Insolvency risk is more important than the market and context risk. This operation makes it possible to analyze the ranking changes that occur in 3 scenarios, and this comparison is made on the basis of the results obtained in the base scenario of the previous phase. From the examination of the sensitivity analysis, the results obtained for the value of the synthetic real estate risk index are consistent with the specificities of each omit zones and robust in terms of weights determined. Finally, the proposed model allows the results to be georeferenced to enable immediate visualization of the distribution of values within the territory of the city of Rome, using the perimeters of the omit zones. The planimetry obtained as a result of georeferencing allows us to observe heterogeneity in the values of the risk index, with peaks in the area outside the Great Ring Road. The results obtained show the presence of 70 areas of low investment risk, 77 areas of medium investment risk, and 66 areas of high investment risk. It is significant to highlight the characteristics of the area with the highest investment risk, which has an average non-residential property sales time of about 21 months, an unemployment rate 9 times higher than the city average, low housing density compared to the city context, and a low level of attractiveness. The best market condition in relation to the calculated real estate investment risk index of 0.29 occur in southeast suburban area. Market characteristics in this area prove to be stable. The quality of life rating is among the highest. There are few cases of archaeological pre-existences that could slow down the execution of real estate projects, and the number of abandoned or poorly maintained buildings is lower. Based on the results obtained for each omit zones, considerations can be made. The indicators that most affect the results, causing an increase in real estate investment risk, are the volatility of sales and rental factors in residential sector, the presence of archaeological sites, and the employment stability. In fact, the IMO areas that seems to have the highest ISR values are also those with disadvantageous circumstances for these indicators. The work described is aimed at providing an innovative ex-ante risk assessment model to support the decision-making processes to be carried out by the public administration and the private contractor with respect to the implementation of urban redevelopment projects. The system produced revealed a relevant number of advantages, including the decomposition of property risk into hierarchical levels, the transparency and simplicity of the approach, the ability to integrate quantitative and qualitative data, the possibility of investigating the importance of each risk factor and the spatial distribution of risks, and the flexibility of the model structure that allows its application at different spatial scales. Future development of the work includes an analysis and subsequent inclusion of additional risk factors indicators selected on the basis of different spatial scale, such as municipal scale. Thank you for your attention.
Thank you so much for your presentation. And please remain in session for every question at the end of the session. Okay, so we can move on to the third paper's presentation, the ones carried out by Michel, Paredes, Leon, Tapias, and Calle.
Hello, how are you? We just sent you an email. It's supposed to be present, but we are doing virtual. Okay.
Sorry, can you repeat? The connection is not so good here.
Hello, can you hear me now?
Can you have the presentation now?
Sure.
Can you share the screen?
Yep.
Okay, thank you so much.
Can you see my screen?
Yes, you can start.
Okay. Well, good morning to everyone. I'm gonna present our paper that is endogenous versus exogenous leadership in teamwork and experimental study. Just a second. Okay. Well, the motivations to do these papers, we always have heard about organization and how in these last times evolved from individual work to more complex workflow systems as known as teams. But teams, the model teams has inefficiency. This inefficiency is focused on the moral hazard and the rewriting. So literature says that we can find a solution from a traditional way, a hierarchical solution.
Hello? There is some connection problem. Non è che è un nostro problema, no?
Possiamo tipo
far abbandonare noi?
No, è bloccato, cioè lo può fare solo lui. Sì, solo lui, perché io non posso toccare, non posso aprire e chiudere queste cose, sennò poi hanno problemi. Tutti,
Sì.
ok. Quindi se può passare questa presentazione al massimo ok, però cioè è bloccato. Sì.
Ok, ha lasciato lui. Ok, perfetto. Riprova a rientrare.
Perfetto, mi hanno sbloccato.
Possiamo andare avanti? Okay, so if it is possible, we can move on to the next presentation, the one carried out by De Paola, Iannitti, Manganelli, and Del Giudice. There are the authors. Okay, so if also this paper is not already done, we can move on to the fifth paper's presentation, and then maybe we can go with the other two that now for which now we have some connection problem. So I go on with the presentation. I have to share the screen. Okay. Here. Here. Okay, thank you so much. Okay. So good morning to everyone. I'm Deborah Nelli, researcher at the Polytechnic University of Bari, and I'm going to present the work entitled A Logical Prerequisite Methodology to Define the Social Discount Rate for the Cost-Benefit Analysis Application, carried out in collaboration with Felicia Di Litto, Pierluigi Marano, and Carmelo Maria Torre from the Polytechnic University of Bari, and Francesco Tajani from University of La Sapienza of Rome. The presentation is subdivided into six sections, starting from the aim of the research, for then moving on to the framework of the research and methodology description, the case study application with the application of the methodology, and then it will be end with the result discussion and conclusion and future insights. Aim of the research is to define and apply an innovative methodology for the assessment of the social discount rate, adjusted according to the effective and the real socioeconomic environmental condition of the European states that in some way, in different way, could affect the cost-benefit analysis economic evaluation of national project to be financed within each of them in order to ensure the goals of equitable growth. The corrective coefficient of the official social discount rate, so the aim of the work is achieved through the implementation of a synergic adoption of multi-criteria techniques, the data development analysis, and the composite indicator system, starting from that is able to aggregate an initial sample of 17 economic indicators, socioeconomic environmental indicators, and the most important issue of this proposed methodology relates to the consideration of the specific importance that each elementary indicator that represent a specific socioeconomic environmental issues of each European state considered in analysis is taken into account in with the determination of a specific weight for that state. Then another important issue of this methodology is the consideration of and the definition of a so-called ideal state, so a benchmark to which each socioeconomic environmental indicator that relate to the other 27 European states considered are compared in order to take in an efficient and a robust way the real condition that characterize each state. Then the final output of this research is an abacus for which the official social discount rate values set by the European Commission, the corrective coefficients obtained by the application of this methodology, and the so-called adjusted social discount rate obtained with the application of the corrective coefficient to the official social discount rate value set by the European Commission, and the reduction, the so-called delta between the official socialist country values and the adjusted socialist country values obtained is reported, is shown for each considered state. So within the several European funding policy, the cohesion fund policies is one of the most important, and it outlines 5 main objectives that relates to the creation of a competitive and smarter Europe, the creation of a net zero carbon economy, and also a resilient Europe, an Europe more closer to citizen, and a social and inclusive environment for all the citizens, and also a more connected Europe from the point of view of the mobility. Therefore, the economic appraisal is a really key important component that can help to the project development, implementation, and also the European funding support. In fact, the economic appraisal can help to support both project developers and evaluators by providing useful information on project selection, by ranking the project according to specific target and certain constrained resources, by scoping out both technological and strategical action also for the early stage of the project design, and also by increasing accountability and transparency of the project selection procedure. Therefore, the use of economic appraisal methodologies is relevant to several proposed sources of European funding in the financial perspective for 2021-2027 period, and for choosing the best quality project which offer the best value for money and also which impact significantly on jobs and growth creation and development. The cost-benefit analysis is explicitly required. The cost-benefit analysis, in fact, is an analytical tool for determining the economic advantages or disadvantages of an investment decision by assessing its costs and benefits in order to evaluate the welfare change that could derive from it. According to the guide, the European guide for the period 2014-2020, a structured cost-benefit analysis is composed by 7 phases. Within them, the economic analysis, within the phases, the economic analysis, the most delicate issue for carrying out a correct cost-benefit analysis is choosing an adequate social discount rate, a social discount rate that is substantially parameters able to reflect the social view on how future benefit and costs should be valued against present ones. Therefore, the proposed methodology tries to overcome some shortcomings that pertain to the existent, more traditional social discount rate assessment procedures, especially from the point of view of the computational and determination of such socioeconomic parameters. And the proposed methodology, in fact, consists into 9 phases. The first one relates to substantially the identification of a sample of elementary indicators, a unique one for all the 27 European states that are considered in the case study, and that are able to represent the main socioeconomic and environmental issues that could affect the cost-benefit analysis implementation. Then, in phase 2, there is the normalization correlation analysis in order to aggregate in the subsequent phases the elementary indicators and remove the ones highly correlated, and so obtaining the final data set able to create the final corrective coefficient. The phase number 3 instead relates to determination of a specific weight of every elementary indicator for each European state through the construction of pairwise comparison matrices, so the application of the analytic hierarchy process, also the involvement of a panel of experts. And the phase number 4 instead sees the implementation of the weighted sum model in order to aggregate the final data set that consists of the elementary indicators, and create the so-called corrective coefficient of the socialist country rate values, that substantially is a composite indicator. The composite indicator obtained from the phase number 4 is also called the actual performance composite indicator of each European state, because it represents at the time of the evaluation the main socioeconomic environmental condition that characterize each state. Then in phase number 5, 6, and 7, the same operation are carried out instead for the creation of the so-called ideal state, so the benchmark one. Therefore, it is an ideal state that has the best values of the elementary indicators chosen for the analysis. For which of them there are specific weight and so importance through the application of an analytic hierarchy process, and also in this case a composite indicator that represents the benchmark of the entire analysis is created through the application of the weighted sum model. Then phase number 8 and phase number 5 and phase number 9 relate to determination of the corrective coefficient through the application of the data envelopment analysis, in particular the benefit of that approach. So the corrective coefficient is obtained as the ratio between the so-called actual performance composite indicator obtained from phase 4 for each of the European states, and the benchmark one obtained from phase number 7 for the ideal state. Then, by multiplying the corrective coefficient with the official socialist country rate values established by the European Commission for each state, according to the existent subdivision into member state and beneficiaries of the cohesion fund, the so-called adjusted socialist country rate values are obtained. Here we can see the case study. The case study relates to all the European states, 27 European states, and is taking into account the subdivision into member state and beneficiary state of the cohesion fund. In fact, for the 12 member states, socialist country rate values equal to 3% is set by the European Commission. Instead, for the 15 beneficiary state of the cohesion fund, a socialist country rate value set equal to 5% is proposed by the European Commission. For each of them, a sample of initially 17 indicators structured into 6 social indicators, 6 economic indicators, and 5 economic indicators is collected and retrieved from the Eurostat database, and they relate to the period between 2018 and 2021, according to the disposable updated data from the Eurostat database. Here we can see the previously mentioned importance that differ from for each elementary indicators for each state. In fact, we can see that, for example, gender pay gap, that is a social indicator collected for all the 27 European states, has different weight, different importance for every European state, and so on, the rental investments or the air pollution rate. Therefore, in this way, we can take into account the real effective importance and relevance that each issue represented by each indicator is characterizing the European state condition. Then, in the creation of the so-called actual performance composite indicator of each European state and benchmark one, we can see here on the graph on the left the performance of each European state and the difference from the benchmark. In fact, there is an average difference of about 30 to 27% points from the 27 European states and the benchmark one, and the highest actual performance is covered by Austria. Instead, the lowest one is covered by Malta. And then by applying the data envelopment analysis, in particular the benefit of the approach. So by
sorry, we don't see your presentation.
Oh. One moment, please.
Pure a me. Vai. Riproviamo.
You sharing the video of the PC, but we don't see. Okay, now it's okay. Now it's okay. Thank you so much.
Okay, thank you. Okay, so by applying the data envelopment analysis and particularly the benefit adopted approach as the ratio between actual performance of each European state and the benchmark one, the corrective coefficient is obtained for each European state. Therefore, by multiplying this obtained corrective coefficient with the official socialist country rate values established by the European Commission, the adjusted socialist country rate values are obtained for all the European state considered. So, starting from an initial situation that is characterized substantially by double difference of socialist country values according to the European Commission establishments, we arrive to a more heterogeneous situation where different socialist country values can be applied for the economic, for the cost-benefit analysis application within each European state. Therefore, the final output of the proposed research is the previously mentioned abacus, for which we can see now the official socialist country rate, the corrective coefficient obtained, and the so-called adjusted one for each European state considered. And among the 27 European states, there is an average reduction of about 32% of the official socialist country rate values, and for all the 12 member states, an average reduction of 30% is observed. Instead, for the beneficiary state of a cohesion fund, get an average reduction of 34%. Among the 12 member states, Denmark has observed the highest reduction, in particular 42%. And the reason can be linked to his lowest actual performance determined after the application of the weighted sum model in phase number 4 of the proposed methodology, as previously mentioned, and some poor performance from the environmental and social point of view. Instead, for among the 15 beneficiaries of the cohesion funds, Malta has the highest reduction, about 60%, and the reason can relate to the lowest, also in this case, the lowest overall actor performance. It's a poor social condition, even if they are within the European average, but they have a consistent and relevant weight. And from the environmental and economic point of view, there are some problems mainly related to the poor renewable energy rate and also the recycling rate of municipal waste or the extension of green lands. From the environmental point of view, and from the economic point of view, there is also an expenditure on environmental protection less than 0.9% of the European state, and this is also it has also a significant weight. So, regarding the proposed methodologies, there are some advantages and also some limitations. Regarding the advantages, the proposed methodology provide for a synergic adoption and application of multi-criteria techniques, data envelopment analysis, and comps indicator systems. And it consists of a relative approach, not an absolute one, because pertain to the real existent conditions, socioeconomic and environmental condition of each state. And it also tries to overcome the shortcomings related to the more traditional socialist country rate assessment approaches that concern the determination and computation of such socioeconomic parameters that are difficult to be determined. And from the side of the limitation of this proposed methodology, there is the limited number of considered indicators related to the issues considered, the socioeconomic and environmental issues considered for each state, and the assessment that is strictly related to the disposable of the updated data, mainly retrieved from the Eurostat databases. So regarding the future inside of this research, it will concern the update of the socialist country rate values according to the ones reported in the economic appraisal by the MECOM for the period 2021-2027, and also then the verification of the consistency and the robustness of the proposed methodology and the following obtained result to a real case study of European intervention within each state. Thanks for the attention. So we can move on to the previously papers presentation. There are the authors De Paola, Iannitti, Manganelli, and Dal Giudice.
Hello.
Hello.
I think I had a problem before. Can I do it now?
Yes. Can we move on with this paper and then proceed with yours?
Okay.
Thank you so much.
Okay. Good morning to everyone.
Morning.
Just a moment. Okay, sharing your screen. Okay. Okay.
Okay, you can start when you want.
Okay. Good morning. The work is entitled Contemporary Housing, the Airbnb Phenomenon and its Impact on the Naples Historic Center's Rental Market, edited by Professor Francesco De Paola, Professor Benedetto Manganelli, Engineer Elvio Iannitti, and Engineer Francesco Paolo De Giudice. The work is structured as follows. Firstly, are provided the definition of gentrification and touristification. There are defined the rent gap theory, home sharing, and the Airbnb system. Afterward is illustrated the real estate market of Naples. Subsequently is defined the geo-additive model, particularly the long-term rent and the short-term rent sample, and finally follow the result and the conclusion. Gentrification is a socio-economic process through which the greater neighborhood or urban area characterized by low real estate price and is gradually transformed into a more prestigious area, resulting in an increased real estate price, improvement of service and quality of the life. This process often involves the settlement of a welfare socio-economic class, often composed of artists, maybe the professionals, who in turn push poorer residents to leave the area due to recent living in the rental costs. Gentrification is often a subject of debate, and is as it can lead to a loss of cultural identity in neighborhood and the marginalization of weaker segment of the population. The touristification maybe is a process by which a place becomes a tourist commodity, where historic centers are invaded by tourist flow, leading to an increase in demand for accommodation, and which can be addressed either by presence of large hotel chains or by the conversion of apartments into short-term rental leasing. The concept of rent gap was formulated by economist Neil Smith in 1979, and it is an analysis of the gap between current rent and potential rent that could be realized after a redevelopment intervention. And in this, Smith assumes that land rent is generated solely by the demand for accessibility. The theory of rent gap is based on the analysis of the building life cycle, and it is characterized by three phases: the construction phase, use phase, and maintenance regime. Degradation phase, obviously, after the phase of degradation, to return to the phase of use, one must go through the phase of renovation. The sharing economy can be defined as an economic system based on the sharing, either for free or for a fee of service on property. It can come in various types: gig economy, on-demand service, peer-to-peer economy, sharing mobility, and home sharing. For an economic model to be defined as sharing, these three elements must coexist: platform, service, demand, and supply. But what is home sharing? Home sharing is a short-term rental model of a room or maybe an entire house where the property owner makes their home available to guests for a limited period of time, usually through online platform as Airbnb. This model has become increasingly popular in recent years because it allows owners to earn extra money by renting out their property, while offering tourists the opportunity to live like a local and save accommodation costs. What are the effects of home sharing in Italy? Taking into consideration first city, Florence, Matera, Rome, and Naples, we have that in Florence, the 18% of the properties in the historic center are intended for short-term rental. In Matera, the 25% of the property in Sassi area are intended for short-term rental, and in Rome, specifically in Trastevere, the 8% of the apartments are offered or rent on Airbnb portal. And in Naples, in the Spanish quarters, there is a higher concentration of short-term rental leasing compared to traditional rentals. Airbnb is an online platform that allows homeowners to rent out their properties for short-term stays, usually for a few days or weeks to tourists and travelers. Homeowners can rent out either a single room or an entire apartment. For our analysis, we consider entire apartments and not single and individual rooms rented out for short-term stays. We compare in terms of profitability apartments offered for short-term rent with those offered for long-term rent in the territory of the city of Naples. The most important areas for published listings are Vomero, Chiaia, Monte Calvario, San Ferdinando, Arenella, Posito, Fuorigrotta, Pendino, and finally San Giuseppe. We have that for the real estate market in Naples, the total listings are 31,843. The sale listings are 22,338. The long-term rental listings are 9,505, and for this case, the short-term rental listings are 7,169, where only the 4,223 are entire properties. The analysis focuses on the three neighbors in the city of Naples, in this case Monte Calvario, Chiaia, and San Ferdinando. For each neighbor, for a period of 13 years, we reported the market values and the rental values trend. So this is for Monte Calvario, the trend of market values and the rental values. The same is for San Ferdinando, market value and the rental values. And finally for Chiaia, the market values in Chiaia and the rental values. The red dots, the red point on the map define all the entire apartments offered rent on Airbnb in the city of Naples. And this is the Airbnb listings for neighbors of Naples, specifically for San Lorenzo, San Giuseppe, Monte Calvario, San Ferdinando, and Chiaia. The special analysis of two types of market. We use a geo-additive model, which allowed us to create two ISO value maps. This methodology allows us to quantify and locate where and how real estate values vary in the urban context. This model is based on semi-parametric regression techniques that use appropriate penalized spline function. For long-term rent, the data sample consists of 53 apartments offered for rent in the 3 neighbors of Naples. The following variables will be taken into consideration are only the floor level, the elevator, that yes or no, 1, 0, and the coordinates. For the short-term rent, the data sample consists of 220 apartments intended for own sharing, where the main variables are geographic coordinates. Then, using the number of rooms in each listing, was determined an approximate square footage for each apartment. By using the function that takes into account the price of the rental rate of the apartment, the annual availability of the listing, and the average occupancy rate of the neighbor, we obtain the annual revenue, which divided by 12 returns the monthly revenue. Here we have the geographical distribution of the sample for both Airbnb short-term rental in orange and traditional long-term rental in blue. Regarding short-term rental, the highest value are on the coastal strip for the properties close to the sea and with panoramic views. Meanwhile, the lowest values are in the Spanish Quarter with properties located on the ground floor or in the basement. Regarding traditional long-term rental, the highest value are found in the area that goes from Toledo straight toward Mergellina, while the lowest values are toward Corso Umberto. At this point, comparing short-term rental and long-term rental, it can be said that in Naples, considering the same qualitative and accessibility characteristics, the income that can be obtained from short-term rental is twice as much as that of long-term rental. The price range, in fact, for the short-term rental varies from 30 to 70 euro per square meter, while for traditional long-term rental, the variation is from only 70 to 20 euro per square meter. Therefore, it can be said that the dynamics between short-term rental and long-term rental are different from each other. Here we have the positive aspect and the negative aspect for short-term rental and long-term rental. The positive for the short-term rental maybe are higher profitability, fewer contractual constraints, unclear regulation, and convenient tax regime. The negative maybe are higher time commitment, unsecured income, higher management costs. For the long-term rental, the positive are secured income, lower management time required, and lower management costs. For the negative, we have contractual constraint, lower profitability, and high taxation. In conclusion, the results suggest that the home sharing sector needs to be regulated in order to address the issue analyzed and avoid competition with authorized hotels, and this can be possible only through control systems that limit the use of home sharing. Thank you very much for your attention.
Thank you very much. Can you hear me?
Yes.
Okay. So thank you very much for your interesting presentation, and please remain in the session for every question at the end of the session.
Perfect.
Thank you so much. So we can move on with Michelle Paredes, Leon Tapias, and Kalle, if they are available.
Yep. Please, can you confirm that you can hear me and you can see my screen?
Yes, we can hear you and see your screen, so you can start.
Okay, thank you very much. Well, good morning to everyone. I'm Carlos. I'm going to present our paper that is endogenous versus exogenous leadership in teamwork and experimental study. I will do it really quick. I know I am over time. And well, our paper starts with the idea about the organization and how in this last time we have evolved from individual job to more complex workflow systems that we call now teams. Teams, they have in their model an inefficiency that the theory called moral hazard of free riding. This inefficiency it's solved by two kind of solution: the hierarchical and the non-hierarchical. We traditionally know the hierarchical solution, where we use, for example, a monitor with the capitalistic firms, someone that control contracts or sometimes optimal incentives. But however, also literature says that we have non-hierarchical solutions, and we have several theories that hasn't been studied or hasn't been proved. So this paper is about this, and we have chosen one that is leadership. The idea about teams, we have to solve the performance trap, because when we work with teams, sometimes we get stuck in some performance. So we want to get out of this trap and get better performance and productivity. And for that, we choose this non-hierarchical solution through a leader. Traditional leaders, if we have seen literature, says that leaders, they have goals, they can convince followers, they also can help to get more productivity, better performance, and also leaders are seen as coach. The objective of this paper is to compare teams with leaderships and teams with no leaderships. So teams with leadership, they should have more contribution than no leaderships, and the effect of types of leadership in team member contributions. In this line, our model is team, and we use the idea about that says Holmstrom's, that there are no function of output distribution differentiable in use individual to achieve efficient team balance. In this sense, our results and the theory that we catch and we use for our model, usually leadership teams says that leader decisions will determine the subject's contribution. But for this research, we have focused in team members' decisions and a leader message that can determine the subject's contribution in teams. The methodology, basically, we use economic theory, in this case, behavioral economic theory, and we also use experimental economics. To do this experimental, we use minimum effort coordination gain framework, the set tree software, and the experimental methodology. That is basically that we can test theories that if this theory in the reality it's doing or it's working. That's why we're testing the teams and the leadership in this experiment. We did in students, they had to decide a contribution to a collective task, and the contribution were from 0 to 50. They had a payoff function that it's based in the minimum effort coordination gaze. They have they were incentivized, according to their individual performance. They had to do 20 decisions per treatments. There were 2 treatments. In the next slides, I will explain about the treatments. There are 4 groups. Teams will remain during the whole experiment, and also they are anonymous. So that's another part. That's another important part of the experiment. And the optimal equilibrium is that the 3 members will contribute 50, the highest contribution. In this line, the analysis that we did is descriptive statistics with central tendency and dispersion, non-parametric analysis, between and within approach, econometric analysis through a panel data. And we had to test a non-hierarchical solution, in this case, the leader, the impact or the effect of a leader, and how this can solve the inefficiency in teams. The existence of a leader will be able to deliver information to the remaining members. The experiment, as I said, we used the minimum effort coordination gain framework. Teams were composed by 3 subjects and with a within subject approach. The thing about the experiment is that we had 3 treatments and we're comparing treatments. The first is a control treatment, a team with no leadership, then an exogenous leaderships. That means some member of these 3 subjects is chosen randomly by the software, by set3 software. And the last treatment is the endogenous leadership treatment. In this case, the 3 subjects, they will bid to be a leader. They had the chance to decide how much they can be a leader, deciding from 0 to 1,000 units how much they will pay to be a leader. That's what we call leader by auction. As I said, they had a payoff function, and if you see, we use the minimum effort coordination games. The payoff function of every member depends on the minimum of the 3 members minus their own contribution. And then we compare, for example, the control treatment against the exogenous leader treatment. And then the second comparison is the control treatment against the endogenous leadership treatment. The hypothesis says that the members of teams with exogenous or endogenous leadership should contribute more than members of teams without a leader. And members of teams with a leader selected by the auction tend to contribute more than members of teams with a randomly selected leader. Results shows that, for example, about descriptive statistics in group 1, that is control treatment versus exogenous treatments, group 1 and 2, they did this game, and they started with control order effects. Group 1 start with control treatment, no leadership, against a random leader. And group 2, random leader, they start playing with a random leader and then with no leadership. It's interesting because when they start with no leadership, they start with really good contributions, and then they get into these performance traps. Maybe we think about this learning effect. That's why in the second treatment, for the next 20 decisions, they have a lower contribution. However, the group 2, when they started with a leadership treatment, they had higher contribution than with no leadership, and that's about order effect. However, when we compare both treatments, we have found that there are differences between the treatments. Then we compare also, as I said, the control treatment versus the endogenous leadership, in this case, leader by auction. And in both groups, teams with a leader by auction, they have better contributions than teams with no leadership. You can see here the mean contribution, and also you can see there are differences between teams with leadership and no leadership. And by leader by auction, as you can see here, also contributions are higher than with no leadership, than with a leader by random, by software. Then we compare, and we have found differences between the exogenous leadership against control treatment and endogenous leadership against control treatment. We did this econometric model. Then you can see in the paper later that is really interesting. And our conclusion were that for our hypothesis 1A and B, leadership has a significant and positive impact in team production. And we induced that in endogenous leadership, the leader by auction can improve leading to more efficient outcomes. And the comparison, it's also rejected against the types of leadership. If you remember, our second hypothesis will compare the types of leadership. We rejected because we didn't have found sufficient enough information to accept this hypothesis. So we have read. We also in our limitations says that they should be more study with a different approach or order effects. This last hypothesis. Sorry. Finally, our managerial implication. This paper gives us some ideas about, for example, recruitment and training programs for leaders, knowing that leaders are an important part of the organization and have an important effect and impact on contribution on teams. Channels of communications are really important, knowing that our paper the leader only had the chance to send a message before contributions in both cases. Sorry, I forgot to explain that. In both leaderships, the leader just had the chance to send a message says, hey, we suggest to contribute this 40, 20 units. And that's one thing that it's important to manage your implication channels of communication, not only messages, all other communication that leader can have with the team. And these are part of our limitations and future research, our experimental approach, the order effects, then also the leader messages may be changing or using another channels of communication also can have an important impact on contributions. And this is it. Thank you very much. Thank you. I think your microphone is off. Sorry.
Sorry. Thank you so much for your interesting topic. And now we can start a brief session for the question or observation for every contribution that we have seen. And I would like to ask you how you would like to involve the leader messages in your future development of this research, and how it is felt by the academic field, but also in the real life, this importance of the leadership, a structured team, and importance of the messages between the leader and teams.
Sorry, I couldn't hear you. Sorry, I had a problem.
So I would like to ask you how you would like in the future insights of your research to involve the leader messages.
Okay, yeah, well, so far right now, the only, in the experiment, the only chance that leader in the event was decided by auction or randomly, they just had a pre-message that just says, please, well, sorry, I suggest to a team to contribute 40, but maybe we have, for the future experiments, they can have the chance to chat with the other partner, with their followers, or not to have unstructured messages. So this can have an impact on the contribution because the relation will be different. And we know that leader, one of the characteristics is the empathy, and maybe changing the messages will have a better impact in the contributions.
Okay, thank you so much. There are any questions about this research, presence, or also in the remote mood? Observation, remarks? Okay, so I move on to ask some question to the first paper regarding the student housing topic. I only would like to ask if the authors think that the student housing could be a really relevant issue in the real estate market field for the futures.
Can you repeat?
Yes, of course.
I am not here.
Yes, of course. I only would ask you if the authors, do you think that the student housing topic will be relevant for the real estate market future developments, in your opinion?
Okay. So the student housing or student accommodation can be considered a win-win investment because it offer a benefit to both student, investor, and so environmental. So the implementation of the innovative and functional yet affordable housing solution in university city is a crucial factor in the urban and social regeneration of the target area. The quality of this isolation help overcome the difficulty that students face in finding suitable accommodation, which currently limit their freedom to explore various study opportunities nationally and across Europe.
Okay.
My opinion.
Okay, thank you so much, Award. Thank you so much.
Thank you.
And another question, the last one for me, but if there are other remarks from the remote mood or in presence, please ask what you want. For the paper regarding the contemporary housing and the gentrification process and analysis also of the rent gap, I would ask to the authors if the proposed analysis and the proposed methodology, they think that could be applied in also the national or international context. Can you hear me? No, maybe some connection problem. Okay, thank you so much. So if there aren't other questions, I can say that the first session of the socioeconomic environmental models for land use management workshop can be considered closed. And this year is the second year that this workshop has been proposed to the ICCSA conference. And it has grown with respect to the previously year, starting with only 3 or 4 papers contribution. And this year we have processed and analyzed about 10 papers. So we are happy to of this result. And we have also research contribution from a different country: Italy, Bolivia, Spain, also America and England. So we are also glad to this. And I would like to say thank to all my workshop organizer colleague, so the Professor Pierluigi Marano of the Polytechnic of Bari, the Professor Marco Locurcio and Felice Di Liddo, also from the Polytechnic of Bari, the Professor Benedetto Manganelli from the University of Potenza, and also the Professor Francesco Tajani from the University of La Sapienza, Rome. And I also thank the disposable, the kindness and availability of the ICCSA conference that gave us the opportunity to meet each other. And I hope to see you in presence maybe in the next year. So thank you to all. Goodbye.
Thank you. Goodbye.
Goodbye. Bye bye. Mettiamo questo. Bravo. Mi si può piaciuta, bravo. Grazie. Grazie. Ho tolto così tanto bruciata per bruciata. Adesso mi bruceranno tutti. 5-10 minuti, prego. Sì, sì. Ok.
Io sono collassato sulla mia, tra l'altro eccola. Sì, normale c'è. E la review no.
La review?
No, dice, è stato mancano ancora le sentenze, sono ancora and the lack of human structure, che deve essere del framework. Ah, poi prima di rimane di office questo investment by the citizen. No,
ma è da vedere, possiamo farlo. Pure io, ma non sto.
Poi manca l'investiva posizione dell'IVA perché non mi sono le attività presenti. Adesso mi penso
questo sei con quei dati, quello secondo me è carino una cosa. Ma forse conviene farlo, no? Cioè non la prossima, perché non credo che finirà sui vostri corsi, però dovrebbe essere un po' per dire mancini. Poi non so se c'è Esther, se vuoi dire Esther, non vorrei parlare.
Io se fosse quello di questa cosa, si davanti, abbiamo parlare alla ragazza 8 ore di cinema di Bravina, però blending, di quello non dare.
Abbiamo come dire, tradizionalmente costi dell'area di grandezza
Però Francesco adesso non c'è dato ancora, quindi si guarda come adesso
ma nel corso di Dio che non so come finire perché quando è la senza che se lo prenda lei continuiamo con un po'.
no, perché questo deve essere lei dà dei titoli.
Appunto.
Poi prendiamo le sale. Cioè, inizio a essere un po' non ci della festa. Non pensare. Allora, impegnati disso, sono riconosciuto. Ma si viene a pochire, ma no, come questo è una cosa che fa proprio. Ma se non si fanno occhi su technical assistance dell'innego che fanno l'Italia. Si vedono sempre canali perché si scrivono il piatto. Lavorano i bambini come trattano per queste cose che non si stai mangiando.
L'ultimo quiz,
Poco di mano la stessa.
Questo sesto, perché credo che di
vogliono essere solo il settimo, però la mappa.